Alright, so this is the calibration software for the new long muscle for my final year project, which is the motion platform. So I wrote some software which interfaces with this rig over here. So I'll first go over the rig real quickly. So you have a load over here that's attached to a pulley, and the load is hanging, as you can see. That's 20 kilograms. That's very, very, very heavy. Have a muscle over here, and the muscle kind of pulls the rope. It's a bit like in the gym, just pulls it on and off, on and off. There's this microcontroller over here. Excuse me. There's a microcontroller over here which takes readings of the encoder over there, which allow me to measure the extension of the muscle, as well as a load cell over here, which sort of helps to automate the entire process. Now, the software at the moment, let me just. This is a messy workshop. Software at the moment allows you to say how many steps per millisecond, how many steps in milliseconds do you want. So it's the delay per step. So goes up by some step, waits a little bit, up by another step a little bit. And this is the step count. So from 0 to 6 bar, kind of like the steps in between in pressures, to put one pressure, then another pressure, then another pressure, then another pressure. Cycle count, this is so you can get a average. So you do 3 full cycles of up, down, and that allows you to get the average at the end, so the average for each one of the readings, which hopefully makes things a bit more accurate. Now, why would I need this? I essentially need to get the distance to pressure mappings. So I first get the pressure to distance mapping. So for one pressure I have this distance, another pressure I have this distance, and that allows me to sort of invert it. And that way, if I want the muscles in the final platform to move some distance, there's a lookup table for that to set it to some pressure, because these muscles are open loop and you can only set pressure, and you don't have any feedback, and that's kind of the pre-testing that's going on within this project. So pretty fun stuff. But anyways, without further ado, you can also define the output, which is just the current the output directory, which is the current directory, and the communication port of the TNC over there, which is a microcontroller. And yeah, so you can now begin the calibration, and the muscle begins flexing. It's pulling the rope, and this at the end will provide us with a table of CSV values that we can then use to I can then use to the project to gain the characteristics of the muscles, as I said before. Alright, I will now proceed to show a quick time lapse of the muscle stretching and going, because it's gonna be here for a little bit of time. Actually, never mind, I set it to only one cycle. I forgot to set the cycle count to let's say 5. So 5 cycles is gonna go up and down, 5 cycles. My bad, sorry. So after running that program and all of that is done, we get a CSV file over here, which has the load for each one of the steps, pressure and distance. And if I run this program that I also wrote, it's a CSV data plotter. I can browse the location, calibration software, and it'll look for these 2 files that the previous program has created, which are the calibration files. It'll plot them. And as we can see here, the blue curves over here represent the up curve of pressure over distance, and so we have the up curve over here and the down curve over here, so it follows that hysteresis loop. These red lines, those are the load readings, and at the moment I don't quite understand why they change so much and why the load values are so different, but it's a work in progress. And yes, this is my update so far on the calibration, and aiming to get the calibration software done and head into next week with tables for 18 kilograms or 20 kilograms, which is over there, 40 kilograms, 10 kilograms, at least 3. And then next week I can just head into incorporating them back into the software and just testing out the longer muscles, which have different characteristics. So yeah, yeah, that's my week 8 project progress so far. Thank you for watching. Have a good day.